Hey guys, so this is just going to be a really brief video about the forces of attraction in different states of matter. So there are three main states of matter. There's also plasma, but we're not going to talk about that one right now. So our three main states of matter are gas, liquid, and solid. And obviously these three have very different properties. And a lot of the difference in properties is due to how strong the forces of attraction are in these states of matter. So it should make sense to you that in a gas, the forces of attraction are very weak. Like the molecules aren't very attracted to each other. And that makes it so those molecules can move around freely and they're not stuck, like clumped together at all. So they have enough kinetic energy to overcome those forces of attraction, and the forces of attraction are weak. In a liquid, the forces of attraction are a little bit stronger. The molecules are held together a little bit more, but they're not held together so tightly that they can't move pretty freely. So liquids can flow, and that's because the forces of attraction are not nearly as strong as in solids. And then lastly, in a solid, the forces of attraction are going to be very strong. And that's why they're solid, because those molecules are held together so tightly that they just do not really move very much. So the lower the forces of attraction in a molecule, the lower the boiling point and melting point. So lower forces of attraction are going to lead to a lower boiling and melting point. And that should make sense because you guys should know that gases have really low boiling and melting points, like way below room temperature. Because at room temperature, they're gases. So that means they must melt and boil at some like negative temperature. Okay, so that's attractions in states of matter. I want to focus specifically on solids just for a second here, and we're going to talk about attractions in ionic compounds. So there's a couple of things that affect the forces of attraction in ionic compounds. So first of all, if ions have higher charges, they're going to have stronger attractions, which should make sense. So for example, just give you a little example here. A positive 2 and a negative 2 ion that are attracted, they will have stronger forces of attraction than, say, a +1 and a -1 ion. And that should make sense. The other thing going on with ionic compounds is that smaller ions are actually going to have stronger attractions. And that's because they can get closer to each other, and so they can have stronger forces of attraction because of that. So for example, if you look on the periodic table, lithium is above sodium, so it's going to be smaller than sodium. So lithium chloride will have stronger attractions than sodium chloride. Right, so that's how states of matter and ionic compounds play into the forces of attraction of a compound. And of course, the forces of attraction determine how high or low the boiling point and the melting point are.